Hello. In this session, we will understand how to interface servo motor with the Arduino board. After listening to this session, you will have a clear idea about what a servo motor is all about, how do we interface servo motor with Arduino, applications of servo motor in real life. Let's understand in detail about the servo motor and its interfacing with Arduino. First, we should understand what is a servo motor. Unlike the motors that we use normally in the electric water pumps, etc., servo motors are different from these types of motors. The motors that we use generally are manufactured to work at certain speeds and at certain RPMs. RPM is nothing but rotations per minute. In servo motors, the speed of the rotation and angle of rotation can be programmed as per the requirement of the end user. Also, they can be controlled by the user, which opens the door to a new world of mechanical operations. That there are different types of servo motors which are available in the market. You can choose the best one for you based on the application that you are working on. If you are handling with heavier objects like metal doors, industrial servos are the best choice. When you go with prototyping purposes, you can use normal servo motors which we have presented in front of you right now. Where can we apply these? That's the best thing that we need to understand right now. Let us find some interesting applications where servo motors can be implemented and used. We can find space laboratories which are having huge telescopic dishes that must be rotated to the desired angle dynamically, as we cannot control the position always manually and it is extremely difficult to do so as well. We need a solution for it. The servo motor is the solution. We can interface a servo motor in such a way that the angle of the servo motor is controlled by the potentiometer. We have potentiometer in usage here. We use servo motor plus potentiometer together to control the angle. It means that the angle to which the servo motor must be tuned can be controlled by using a potentiometer. So a huge telescopic dish can be seamlessly controlled by a small knob at your desk. This is a beauty and we are going to demonstrate the same in the practical part of it. Here we are going to see about the connection details. As we know, we need to have servo motor, potentiometer and the Arduino board connected to each other to get the interfacing and the talking to be done perfectly. We will follow the same details as we have presented in the table in front of you. The first column shows the Arduino, the second column shows the pins of potentiometer and the third column is representing the servo motor. The 5-volt pin of Arduino has to be connected to the leftmost pin of potentiometer. 3.3 volt of pin of Arduino has to be connected to the servo motor's VCC. Ground of Arduino has to be connected to the rightmost pin of potentiometer and ground of Arduino has also to be connected to the ground of servo motor. The 5-volt pin of Arduino has to be connected to the output of the servo motor. The A0 analog 0 pin has to be connected to the middle pin of the potentiometer. Once we do this, it is all done. The output pin of the servo meter can be connected to any of the PWM pins of Arduino. These can be identified by the tilt symbol on the Arduino board and we have discussed this in the past as well. It is the time to code right now. Servo.h is an inbuilt library which comes along with the Arduino IDE installation. So our job is simple. We need not install it separately. We need to just import servo.h library for accessing the servo functions. It has the functions to generate the PWM signals according to the given input. We need to declare a servo class variable for its easy access. Here, my servo is the variable. Servo pin is used to initialize the servo motor pin which is connected to digital PWM pin 5 which we have shown you in the connection diagram. Let's see the coding part of it. Hash include servo.h. This is the servo library which is available by default during the Arduino IDE installation. Servo my servo. My servo is nothing but an instance of servo class. So you can create it and you can have any name there. Here we have used my servo. Int servo pin is equal to 5. We have initialized the servo motor pin with digital PWM pin number 5 as we have shown it earlier. Now, pot pin is used for initializing analog pin 0 A0 as potentiometer pin. Val is used for storing the potentiometer readings. In the setup part, pot pin is declared as input port as we are receiving analog data from potentiometer continuously. Servo's output is attached to the desired PWM pin on the Arduino using servo.attach command. You can see the coding right now. Int pot pin is equal to A0. We have initialized the potentiometer. Int val, we have got a variable val, and that will be useful for storing the potentiometer readings. When you get into the setup, pin mode, pot pin is set as input. The servo's output is attached to the desired PWM pin on the Arduino with the help of myservo.attach servo pin line that you can see in front of you now. We are left out with the loop part. So what is loop? Loop is where the work that has to be done continuously will be coded. In the void loop, we read the value from the pot pin and store it in the variable val. Now, this value is mapped to another value in the range of 0 to 180 because servo can rotate only to the maximum angle of 180. For better understanding of map function, we have used it in the code. You can see that. To understand it better, imagine you bought 10 chocolates for 5 rupees and then what is the price of one chocolate? This is the basic fundamental math done by the map function. This mapped value is written on the servo motor specifying to rotate to a specific angle according to the potentiometer input. Now let's come into the coding part of the loop function. Val analog read of pot pin. This continuously reads the input from the potentiometer pin. Val map, you are using val 0, 1023, 0, 179. Map the potentiometer to match the servo angle is what is done here. And this is very important. This has to be understood clearly. Then myservo.write val. Finally, we are writing it. And then we have some delay here just for us to see what is happening. You could see the real-time demo right now. With that, you will understand this process easily. In this tutorial, we'll clearly understand how do we control a servo motor with a potentiometer. You should make the connections as we have presented you during the theoretical session. Just follow all the guidelines and do the interfacing so that the setup will be fully functional. You can see that we have the potentiometer and servo motor clearly interfaced, and you can do the same with the guidelines provided. Once it is all set up, you need to go to Arduino IDE where the code is readily available for us to run. Select the appropriate COM port, select COM3 here, and you can upload the code. Uploading happens after compilation as ever, and once it is done, you are all set to see the demo. Now once the uploading is done, you will have to open the serial monitor and there you can get the output visualized. Now you can see that we are reading the potentiometer value and servo angle. When we tune the potentiometer, the servo motor gets tuned appropriately. You can see that when I tune the potentiometer in anti-clockwise, the angle increases for the servo motor. When I do the clockwise rotation for the potentiometer, you can see that the angle decreases for the servo motor. I'm doing it right now and you can see that the angle gets decreased. More the moment I give in clockwise, more the angle gets decreased. More the moment I do in anti-clockwise direction, the angle increases. That is it. You have interfaced the potentiometer with servo motor for its controlling.